So, if there's something I've done a lot of, it's study the basics of game development over and over again. I've written hundreds and thousands of words on programming design patterns, best practices, and when it's okay to do something that other people are saying that you shouldn't do. And in all of that research, when I break down the reasons that you should or shouldn't do something, it always comes back to one thing. One reason to do things in a certain way, and one reason that you can check against to see if you're doing something the wrong way. In this video, I'm going to explain exactly what that is and how you can use it to make your game project easier to work on, which can be a lot more important than you might think. One of the biggest obstacles to your project in the early stages, and especially if you're new to making games, is not being able to progress it beyond a certain point. This happens when your game gets too difficult to work on, so specifically when it's not clear what you should be doing next, which means working on your game, it just stops being fun. So you stop doing it, or you restart it, or you do something else. But what you don't do is finish your game. So what's the solution? Of everything that I've researched, the one reason behind every best practice recommendation is to keep your project easy to work on, which is a very broad statement. So what does easy to work on mean? Well, easy to work on could mean that you don't do things that you find difficult, like writing code, for example, or it could mean that you keep your project small so it's easy to visualize and keep track of. And these are useful tips, but they won't always be relevant and they won't apply to everyone. Instead, there is one interpretation of what easy to work on means that will apply to just about any project. And that's that easy to work on really means easy to change. A project that's easy to change is easy to refactor, it's easy to visualize, it's easy to extend and modify, and it's easy to finish. Put simply, when your project is easy to change, every other aspect of it becomes easier too. After all you're really doing when you work on a project is changing it. So the easier that is to do, the better the game is likely to be as a result. Because if you want to build a game that's good, you need to get out of the early concept stage as fast as possible. And you need to create something that is playable so that you can try it and see if it's fun. And when it's not, because it might not be on the first go, it'll be easy to modify so that it is. This is so important. The ability to iterate your project is, in my opinion, the most effective way to make a game better. Because if you can't change it easily, you're stuck with a design path that you started with on your first attempt, which, if it's not fun and you can't change it so that it is, you're going to be stuck with it. Meaning that if you want to improve how easy your project is to work on, asking yourself if something is going to be easy enough to change later can be a very simple and very effective way to do it. But this is all well and good in theory, but easy to change is still a very abstract concept. So what does easy to change mean specifically? Let me give you an example. This is my car, a 2013 Vauxhall Astra J in flame red. It's nothing special, but if I wanted to make it better by changing things, I could. Let's say that I wanted better lights. I could take the old ones out and put any new ones in that fit the same sockets. This is because the lights are self-contained. They have one input in a certain format and the car has one output in the same format. Meaning that so long as the light I put in has the same type of interface, it will fit and it'll work, making it easy to change. However, if I wanted to change a part like the engine, it wouldn't be nearly as simple. The engine is connected to multiple other systems, meaning that just taking it out would break other parts of the car. However, even with a part as complicated as this, the inputs and the outputs, just like the lights, they each have their own interface, meaning that so long as whatever I put in its place meets the requirements of the systems connected to it, it will still work, and it's still relatively easy to change. I probably annoyed my mechanic by saying that. Sorry, Richard. So what's my point? If the lights are easy to change and the engine's easy to change, what does difficult to change actually look like? Well, if I put my foot on the brake lights light up. But the brake pedal isn't directly connected to the bulbs in the brake lights. Instead, there's a switch that recognizes when I'm pressing down the pedal, There's a connector to the light cluster, and then the bulb itself is connected to the socket. There are multiple points of separation between the pedal and the actual bulb, making any part of the system relatively easy to change. But what if there wasn't? What if the brake pedal was directly connected to all of the systems it interacted with? So there's no switch, there's no interface between the light cluster and the car, there's no socket for the bulb, it's just one long wire from the brake pedal to every system that it interacts with. This makes it very difficult to change, because if you want to change your brake light, or change your brake pedal because it's getting worn, like mine is, then you had to take half your car apart just to do it. Now, I know what you're thinking. You're thinking, one, who would build a car like that? And two, what does any of this have to do with game development? Well, quite a lot actually. In programming, a dependency like this, where one system directly interacts with another, is known as tight coupling, and it's surprisingly easy to do. So for example, let's say that you have a ship and you want to give it the ability to fire weapons. So you create a weapon script that detects input and fires a projectile. Both of those things are happening in one system. So is that a problem? You ask yourself, is this easy to change? If you wanted to swap out the weapon, you'd have to recreate the input part of the script. And if you wanted to swap out the way input is handled, such as replacing manual input with enemy AI, for example, you'd have to recreate the weapon part in that script too, which doesn't make sense. This is the programming equivalent of replacing your brake pedal when all you need is a new bulb. So you separate the two parts into different systems, input and weapon, and now it's easier to change. But are they really separate? The input class still directly references functions in the weapons class. The problem with that is that there's no abstraction between the two. The input class needs the weapon class, and the weapon class needs the input class, meaning that you haven't really separated them, you've just written one script in two places. This means that the two classes are still tightly coupled. It doesn't matter that they're in different parts of the theoretical car, there is still one long wire in between them, meaning that removing one breaks the other, and vice versa. So what's the answer? If the systems were truly easy to change, it would be possible to remove the input class and put an enemy AI script in its place, or swap out the weapons class for a different type that has the same inputs, without breaking anything. This is what abstraction looks like. And put simply, abstraction is just making something less specific. And there are a few different ways that you can do that, such as by using interfaces, which would replace the connection to a specific type of class with a connection to any type of class that conforms to a particular interface type, or with events where the two classes don't directly interact and the weapons class just listens for global inputs that would trigger it. You could even use inheritance to separate out the parts of each system that are the same between all of its variations. How you do it is going to depend on the engine that you're using and how you're building your game. What's important, however, is that in all of these examples, either part of the system is still easy to change because it's been properly separated using abstract connections. So much so that in this example, I can remove the input script from an object and replace it with an AI script while the game is running without causing an error. So does that mean that you need to create abstract connections between all of the systems in your game? Not exactly. The spirit of easy to change works both ways, with an emphasis on the word easy, meaning that you shouldn't try to make your project more modular if it makes it harder to work with as a result, since that kind of defeats the point. An example of this is the single responsibility rule, which is one of the 5 solid principles and arguably the most important. But it can be easily misunderstood to mean that every class or system in your game should only do one thing, which, depending on what you consider one thing to be, can quickly become impossible to work with. Instead, single responsibility has since been clarified to mean keep the things that change together, together. In my example, that means being able to swap out the input system without affecting the weapon system. But it stops there. If I decide that the weapon system is only ever going to fire projectiles, so it's never going to do something like fire a laser that might mean that I need to change how part of it works, then I don't need to split it out any further, and keeping it together actually makes it easier for me. It's a judgment call, and when you're making your game, you'll need to decide for yourself where the balance of keeping things simple versus making them easy to change actually is. But if you can do that, you'll end up with a project that's much easier to work on and much easier to keep working on. Let me know in the comments how you're keeping your project easy to work with, and if you're interested in learning more about the solid principles, watch this video next, where I break down the 5 rules so that you can actually use them in your project.